In this lecture, we will take a quick look at DevTools, as this is a very important toolset that we will be using throughout this section. So as we will do for multiple of these examples, we will take a look at the default counter application. And as you can see, it's running. And at the top right in Visual Studio Code, we have the option to say Open DevTools Widget Inspector page. And we can also bring up the command palette, and then we can open DevTools from here. So as you can see, I just typed in dev, and then we can say Dart open DevTools. So either of these ways is fine, and that will open DevTools. And in Android Studio, it is very similar. We can open the DevTools by clicking this icon over here, or by clicking Open DevTools in the Flutter Performance pane. Or we can just bring up the command search and just type in DevTools, and that should open DevTools as well. So let's actually open it. So I'm just going to tap the DevTools icon, and now we've opened DevTools, and this is opened in the browser. So as you can see, we are connecting to localhost and port 9100. So this may be slightly different depending on the port it opens on, but the main point is that Dart by default creates a service that exposes the DevTools. All we need to do is connect to it. So we're going to give a quick overview for each of these different tool sets. However, in later videos, we will take a more practical look at these tools and use them to actually analyze our applications. So for now, we're just going to gloss over all of the features. And at the top left, you can see we have the Flutter Inspector, and the Flutter Inspector is only available in debug mode. So if we bring up our emulator, you can see that we're running in debug. And what the inspector allows us to do is inspect all of the widgets and also see the associated render objects. So for example, for the My Homepage widget, there is a linked render object with this particular ID. And in later videos, we will explore this a lot more. And then additionally, we can configure a number of different debug tools that we can use. And we won't be covering everything that is available in DevTools, so I definitely recommend that you explore this on your own. And additionally, the toolset is always expanding. So depending on when you watch this video, some of this may no longer be relevant, or there may be a whole bunch of other features. And then next up is the timeline. And you can see that the timeline actually gives us a warning if we're not running in profile mode. And there is a dedicated lecture explaining why profile mode is important for debugging, as well as why it's important to run on a physical device. So currently we are in debug mode and we're running on an emulator, but we only want to do some quick exploring of DevTools. And at the time of recording, there is a small issue with DevTools, or an issue on my side. Normally you have this frame rendering chart that is constantly showing at the in the screen over here, and that is similar to the performance overlay. And the performance overlay and the separate threads that are in Flutter is covered in a dedicated lecture as well. So if you open this yourself, you might actually see additional data displaying over here that can provide additional frame information. However, all of this information is also in the regular timeline, and that is what we will use in this video, and we will actually use it in most of the other lectures as well. So if we unselect show frames, then we have the option to record our timeline. And the timeline shows the CPU processing of certain events over a given time. So to actually get some data, we need to record. So now we are recording all of the events, and as I hit the add button over here, we should be recording this information. So if we say stop, we will get information for all of these separate frames, as well as the events that happened on them. So as you can see, we have the UI thread and the GPU thread and this unknown one. I actually believe the unknown one is the rasterized thread. In later videos, we will go into more detail discussing this. For now, I want to take a look at something that will be a bit more familiar, and we discussed this in the rendering pipeline lecture. So as you can see, we have this vsync process callback, and this is basically an indication for each frame tick. So the vsync basically creates a callback that says every time the frame gets updates, we want a certain callback to be triggered. And all of these frames that you see This one over here is actually the build that we are calling. So if we expand this a little bit more, and you can see we have the CPU flame chart, and the CPU flame chart shows the CPU samples for the selected frame event. So the selected frame event in this example is the build event. So this is shown as a top-down stack trace, where the topmost stack frame calls the one below it, and the width of each stack frame represents the amount of time it consumed the CPU. So if we find stack traces that are very long, then those are good indications of points that we may need to look into for why they may be consuming a lot of CPU time. So in this particular instance, you can see we are doing a lot of update children, a lot of performing rebuilds, and again update child, all of these again and again. And these updates and update child, these are called on the element, as we saw in the previous lecture. So this means that we are traversing the element tree from the top to the bottom, and we are updating the relevant elements to associate to new widget configurations. So as an example, if we go back to Flutter Inspector, then the element tree would be similar to the widget tree, except for the fact that they're elements, and it goes from the top to the bottom and just updates all of the elements to have the new widget configurations. But actually that is not important. The important bit is to understand that we have this information to actually take a look at what is happening in each frame. Though having all of this information is not necessarily useful. I mean, this is so much info, where do you begin? And for that, we have a number of other tools and benchmarks that we can use to assist us in identifying performance issues, which we will explore in a lot more detail in later lectures. But as a quick example, something that is definitely worth it to do is also saying the track widget builds over here, or to enable this. And this is a flag that can be enabled programmatically as well, and also from the command line. But this is the easiest way to enable it. So in DevTools, we will enable this, and I'm going to clear and then record another series of events. And now if we say stop, we will actually see that our build is slightly different. Now the build tracks all of the widgets that are built when we perform a rebuild. So as you can see at the top, we have the My Home page, the scaffold, and then it goes down, down, down. So all of this just gives us information of all of the widgets that were built in that rebuild. This shows us a more detailed overview of all of the widgets that were built. And now if we, for example, select the scaffold and just explore how the scaffold was rebuilt, the information is a little bit more contained and a little bit clearer. In the same way that we have the CPU flame chart, we can also take a look at the call tree and the bottom up, which we will explore in a moment. But yeah, as I said, the timeline is very useful and we will be using it a lot throughout this section. However, DevTools is still being developed and there are still some features that are missing. And in the next lecture, we will take a look at the Dart Observatory, which is a toolset that is used by the Dart programming language to also do debugging and to trace your application. And that toolset is a lot more mature, and in certain regards, it is definitely a lot better to use. However, what makes DevTools a lot better for us as Flutter developers is the fact that everything is very related to Flutter development. So it tries to show us the stuff that we would be interested in as Flutter developers, along with handy configurations such as the performance overlay flag that we can just enable over here. If we continue to explore the other features that's available in DevTools, you can see that we also have the memory tab. And for this, we will also have a dedicated lecture. But the main idea is that we can get a snapshot of the current memory that our application is using. So we get a snapshot of the heap. So as you can see, we get an idea of what classes we are using and how many of those classes and the size for those classes. And this can be extremely useful in certain applications. But later we will do a practical example exploring this. And then finally we have the performance. And in a lot of ways it's similar to what we just saw, except the timeline allows you to dig down into a certain time event. The performance is a more realistic view of the entire app's performance. So for example, if we record and do a couple of tabs and say stop. It will basically concatenate all of the events and all of the methods that were called and group them as one event. So for example, if our application was doing something very resource intensive or taking a lot of CPU time, then we would be able to see this in the CPU flame chart as a node or as a graph that takes up a lot of space. And later on in later lectures, once we delve into practical examples, we will actually see how the performance tab can be useful. And a quick explanation for the call tree. So this view shows the method trace for the CPU profile, and this table is a top-down representation of the profile, meaning that a method can be expanded to show its callees. So as an example, here we have all, so this is where everything happened. The method is not actually called all, it just means it represents everything that happened. And then we can dig down and see exactly what a method called. So for example, the update method would call rebuild, which would call perform rebuild, update child, update, etc. And then to the left, we have information about the time that a method took, so the self time, and the total time. So the total time for all would obviously be 100% because it takes all of the time. However, the actual method didn't take a significant amount of time itself. A single method that did take a lot is this vsys call, for example. And then the bottom up is just the reverse. So it is a bottom up representation of the profile. So that means that each top level method in the table is actually the last method in the call stack for a given CPU sample. In other words, it's the leaf node for that sample. Everything that we have discussed now in the performance and the timeline and even the memory will become a lot more useful once we do a more practical example. But I did want to make a dedicated video just to bring you up to speed with the different tools and all of the terminology behind them. In the next lecture, we will take a look at 2 additional ways that we can do debugging and tracing.